All right, our last couple of examples here from section C-8 as we wrap up Unit C have to do with perpendicular lines, writing equations of perpendicular lines. What we know about the slopes of perpendicular lines is that they are opposite reciprocals, and that's really, really important to know, and we'll use that here. Question 1, lines L1 and L2 are neither horizontal nor vertical. They're slanted. Are they perpendicular? So let's check their slopes. Let's look at rise over run. So let's look at line 1 first. We're going to start at this point, and we're going to do our rise over run to that point. So L1, the slope will be, and I'm going to go down, so that means I'm going to go down 1, 2, 3, 4, 5, 6 to this level. So that's -6. And then we're going to go to the right, 1, 2, 3, 4. So that's down 6 and over 4. L2 is over here. So I'm going to start at this point, and I'm going to go up to that point. So we're going to rise 1, 2, 3, 4, 5, 6. So that's 6 up. And then we're going to go to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's 9. So now let's reduce these. So this would reduce to -3/2. This would reduce to 2/3. And those numbers are indeed opposite reciprocals. If I take the opposite of negative, I get positive. If I flip the 3/2, I get 2/3. So yes, these are indeed perpendicular lines. This would be a 90-degree angle right there if we needed to know that. All right, our last example here is to write the equation of a line perpendicular to this line that contains that point. So I'm going to actually show you two ways to do this. The first way is using point-slope form, and then we'll use slope-intercept form. The first thing I need to know is the reciprocal, the opposite reciprocal of the slope of this one. So the slope of this is 1/5. So the slope of the line I want is the opposite reciprocal, which would make that negative, and then 5/1, or just simply -5. So I no longer need that equation. I found the slope of the line I'm interested in, the one perpendicular. So now I can call this x1 and y1. I can plug it into my point-slope form, and I'll get y minus -4, which would be +4, equals m is -5, and then x minus my 15. I could put that in slope-intercept form by distributing and solving it and making it y equals mx plus b, but I'm going to show you a different way to do this. So let's not even use that answer. Instead, let's use this information and this equation. So what we could do is we could just call this x and this y, and we could plug y, which is -4, equals m, which would be -5, times x, which is 15, plus b. If I solve this equation for b, it'll give me my y-intercept. So if I do -5 times 15, that gives me -75. And if I add 4 to both sides, I would get, I'm sorry, I don't want to add 4 to both sides. I want to add 75 to both sides. I'm solving for b. That's going to give me b equals 71. That's my b value. I already know that that's my m there, so I can write y equals -5x plus 71 as my slope-intercept answer. And that would be the same answer I would get as if I would have distributed the -5 here and then moved that, and I would have got the same answer there.